So now, on to the fun stuff. First up at the build track for Atlassian Summit, we have Vincent, who has traveled here all the way from Sydney. He's an internal Atlassian. However, he is not Australian, he's actually Dutch. So you guys may or may not know this, but the Dutch are known for being some of the tallest people in the world. Vincent definitely holds up to this standard. He's going to be talking to you about microservices today and leave you with 5 tips and tricks to head back to your team to be able to implement right when you leave this room. So without further ado, Vincent.
Thank you, Justine. Hi, good morning everyone. Thanks for showing up. I hope you all enjoyed the keynote. Like Justine said, I'm Vincent. I'm a dev manager for Confluence. And today I would like to talk about microservices. I would like to start with the issues we face with general software development, how microservices might help, and the things we've learned building them. And at the end I will try to wrap it up and see to send you away with some tips and tricks you can apply directly in your own situation. So let's talk about the issues you have first. I'm not going to talk about Jira, so don't worry, you don't have to leave the room. The first thing that will happen when your team grows is the fact that you will slow down. The amount of code you'll have will grow. Your IDE becomes sluggish, your pull requests become harder, your builds get slower, your testing becomes slower. So as a team, when you grow, you start to slow down. The second thing is like when you add people to your teams and when you start to grow and you're going to have multiple teams, you start to conflict with each other. So you're not independent as you want anymore. So you start to blame other teams for not making your deadlines, which is not always necessarily true. When you get conflicting builds, you push the same thing to master and some stuff breaks. So life gets harder. The third thing is like your technology will age. At some point you make a decision about a technology you would like to use, whether it's a framework or a language, which seems to be a good idea at that point in time. But a few years later, new frameworks arrived and you're not, or your implementation of it isn't that good as you would expect it to be. But changing that is really hard. For example, for us in Confluence, it's really hard to, for example, get rid of side mesh, which we're not a big fan of anymore, but hey, some founders decided to use it a long time ago, so that gets harder and harder. So how does it relate to microservices? I think microservices can help for some of these problems quite a bit. First of all, they're really small. So you're learning at least one thing today, microservices are small. And a big advantage of having small services and having a small code base is different things. One main thing is easy for a developer to get your head around it. When you have a really large code base, to become master of the code base, that gets harder and harder. The second thing is all the tools you use remain fast. So your build remain fast, your tests remain fast, your deployment can remain fast. So that's a big advantage. They also maintain an independent lifecycle. I think that's really important to it. It really helps for you to stay independent as a team. So you're not too dependent on other teams anymore. Obviously, you still probably will depend on teams for features of service they have to provide for you. But from a technical perspective, you can move as fast as you can. And you can optimize your team to go as fast based on the processes and tools you use within your team. The third thing I would like to mention is the ability to choose the right tool for the right job. If you're in one big app, at some point you made a choice for a technology or a framework, and you try to solve all problems you face and all the features you would like to build with that specific tool. If you're in the microservices world, you can make change there. If you have a certain problem that requires a specific tool, you can make the decision to use such a tool. Of course, you want to keep the right balance between the amount of tools you have, because you don't want to get too many, because then it gets harder and harder to get your head around and be productive if you switch to a different service. Last thing I would like to mention is they're replaceable. And I'm not going to say that you're going to replace every service instantly whenever you build a new feature, but whenever you made a mistake for a framework you've chosen or a technology you picked, you have the ability when adding a new feature by adding a new service to either pick a new technology and make the same mistake all over again, or create a different implementation on the technology you have chosen and create better patterns based on the things you've learned. And if some service is really painful, you can decide, hey, I'm going to replace that one because it's too painful on the team and we're losing too much velocity with that. However, when you choose a new paradigm, you have a lot of questions coming at you. So you have a lot of decisions to make. We had the same issue as well. So in this talk, I hope I can share a few lessons we've learned and fast forward you to the top. So you can walk away and say, hey, the guys at Atlassian did it like that. It might be helpful for us as well. However, microservices are not a silver bullet, so they might not be applicable for your organization or for your team. The problems they can solve can be solved in different ways as well. And they introduce different problems as well. So they add complexity to the system. So let's have a look at a few examples of microservices at Atlassian. I will start with Confluence because that's what I work for. And the first service I would like to mention is file store. If you look at Confluence traditional, we store all of our attachments within the app itself. We store it in our own data center, which you have to build capacity for. If you look at files, so we were able to design a specific service for storing files. You were able to store it to build one in AWS without re-architecting the whole application and really optimize for durability of our files with all the optimized backups, etc. we needed. And creating space in our own data center, which you can use to run Confluence itself instead of storing files and attachments. Related to that is file conversions. Whenever you upload an attachment to Confluence, you basically, we start to convert files to make it viewable in your browser. Normally we did it within, did all the processing within the app. If a big file came along, it could even crash the app, and it took resources to actually do the processing, which hit performance for Confluence itself. By pushing the way to a different service, we were able to choose the right technology, do a lot of batch processing. And whenever something goes wrong, it doesn't affect Confluence itself, and it doesn't impact any I/O and performance for Confluence, which is a great benefit. Last thing I would like to mention, it was mentioned in the keynote as well, if you're a Connect or a Connect add-on developer, it really is kind of a microservice. It's something you host and run yourself, and I think it has all the attributes for a microservice. The second example I would like to give is within identity. The identity group in Atlassian provides all login systems for our cloud offerings. So if you look, for example, at the login screen, it's a really small domain. However, when it goes down, it's really impacting the ability to use our software. So it's really important to remain up and to have a really high uptime. So our login screen is really optimized, our login system is really optimized for uptime. And it's really important that it's available as much as we can. If you look in the same domain, an avatar service, it's related to identity. It's still important, but it's not as critical as a login system because we're not happy if you can't show faces within a software, but it's less critical. So you can really balance the requirements you have regarding uptime for your services. So even within the same domain, you can make different choices based on the requirements you have. We ended up adding around 10 servers in that area and building out features with these characteristics. So these were some examples. So how does it look like when you start to build microservices? So what are the first steps you have to do? The first thing I would like to mention is you have to build a pattern. You're probably going to add more and more microservices to your environment, so you have to be fast at it. So it should be an easy thing to do to set up all the things you need for your service. So how does your service look like? How are your builds organized? How are your repositories organized? So if you look at how you should organize your service, you already end up quite quickly at the 12-factor app. It's written down by the people from Heroku, and it's a really good guideline what kind of attributes your service should have. I'm going to hit around 8 during this session, so come and find me if you find all 8 of them. I try to get you a special t-shirt. I would like to start with how a service looks like and the attributes of a service. First of all, and it's also defined by the 12-factor app, is like you really have to expose the port to expose its functionality. It's not something you run in a Tomcat or a web container. The application is responsible for it itself. So you expose the port, and that's how you communicate with the application. And that's the only thing the environment needs to know about the application. So you have a port, and that's how you communicate with the application. The second thing is it needs to have a health check. So the system around the service needs to know whether the service is still capable of fulfilling its service. And lastly, in case of when something happens, it needs to be stateless. So the health check will determine whether it's still healthy or not. If for some reason the service dies, we need to spin up a new one, and we need to do it quickly. And the only way we can do it if a service is stateless. If you look a little more to a health check, what does it do? It's actually pretty simple. If the service is healthy, it's 200. If it's not healthy, we return something else than 200, which basically means the service doesn't function anymore, so we should get rid of it. Spin up a new instance and see whether the problem gets resolved. If it continues to happen, probably there are some bigger problems, so we should start to investigate. But if it's a local problem for the instance itself, the system will become self-healing, because we spin up a new instance, kill off the unhealthy one, and we are able to continue to process. So what kind of information do we have additionally in a health check? There's some metadata about the service, but for us the key importance is like which commit result in the deployment of a service. So you see a commit hash here in the metadata. It's just a simple JSON blob that will be returned by the service. And it gives some additional information about the service, so you can plot some additional metadata if you would like. We also send out like a deep check. So if someone is interested or some monitoring is interested in more detailed information about the service, we also provide, hey, with what kind of other resources does it interact with, and is it able to reach those services and get some more detailed information. So this is kind of a few attributes of a service to make sure you can just drop it in your environment, and the environment should be able to run it. So once you have your service defined, you have it up and running locally, you have to think about, hey, how do I organize my source code and how do I organize my builds? We've made a decision to have one repository per service to keep it really small and isolated, and also to have one build per service to keep it fast and snappy. It did give some problems as well, because source discoverability becomes harder. If you want to have big refactorings, it becomes a bit harder as well, because your source is scattered. Some big companies like Facebook and Google, they're more towards the mono repo, where you have all your code in one big repository, but that gives some problems around tooling as well, and reduces the agility of your system. So it depends what you like. This really works well for us, and it's really well supported by the tooling we have. So let's have a look at the source repository. Like to get rid of like the problem of not being able to find the code. We use Bitbucket projects a lot. Maybe organize a service around a certain domain and have them all in one place, so it's still easy to find for developers. So you mitigate that issue. The other advantage I would like to highlight is the build time. So this is an example of a bigger service, or a project, I should say, where the build time is 54 minutes. That's not necessarily an issue, but if you look at 54 minutes, it's actually not the slowest build we have at Atlassian, like we have way slower ones. The feedback loop for the developer is really high. So you have to wait almost for an hour to get the feedback, hey, did my change impact the result? If you want to have it as part of your branch, it can take a long time before you get the feedback and before you know whether you want to merge to master or not. And more importantly as well, your mean time to recovery is almost an hour. So if your deployment pipeline is optimized and you can deploy once you have a green build, it takes you almost an hour to recover without any hacks in place. If you look, for example, at a build of one of our microservices, it's only 1 minute. To be honest, I took the fastest one we have in place of a smaller service. But in general, the build time is around between 1 and 10 minutes. So your mean time to recover is really fast. And also the feedback cycle for your developers is amazing. It's a really great experience. So as a developer, you get really used to it, to have a really fast feedback loop and not have to wait for a few hours to say, hey, it took me a while, hey, what change did I make? I went to another issue, I went for a coffee and still don't have any feedback. So both your mean time recovery is a good benefit, plus the fast feedback loop for your developers. Second thing you have to think about, hey, how do I configure my service? Traditionally, and we still use a lot of Atlassian, we have configuration tools like Puppet or Chef or Salt, pick your flavor. The problem with those tools is that you generate a different life cycle of the information you have. So you have to wait where the Puppet applies to make sure the latest configuration has been applied to your environment. That's one problem. The other problem is like you create mutability in your system. So Puppet runs and you suddenly have configuration changes and you don't know the impact of those. So we try to keep a configuration as close to a service. And actually most of the configuration is part of the same source stream. This is a slight violation of the 12-factor app because it actually says, hey, you should keep them a bit separate. But for us, it works really well. And to prevent repetition, we have configuration per environment, where we have the configuration per environment, and we have configuration per service. We use a really simple JSON format for a configuration where we can use includes. Basically say, hey, this is how the service is configured, and if there is common configuration, which is common for the service itself, we basically import it and include it in the main file, which gives a really nice hierarchical structure to organize your configuration without a need for heavy tools like Puppet or Chef, and it makes sure it is completely bound to your service, so there's no mutability in your system, which makes it really easy and you can be really sure about the configuration you use for that specific build of your service or the specific instance of your service. One obvious note, don't store any secrets in your source code. That's not what you want. We push them as part of environment variables. That's what we can do with all our configuration to eventually override it if that's required. And don't store any passwords there. So we have a repository and we're able to deploy it. So how do you organize your deployments? Our deployment pipeline looks pretty simple and it's kind of straightforward. We do a commit to master that runs the build and the test I've shown you before. We do a release, and the important thing of the release is the build already produced the artifact, but the release actually tags it as a certain release by giving it the release number and makes it available to pick that specific release and spread it across the different environments we have. We usually have 4 environments. Development, staging, where development is for the team itself. We have staging, which can be used by different other teams integrating with it. And we have 2 production environments, one the main one and the other one for disaster recovery, where which is being used in case of a big disaster, where we can switch over to a different region to provide the same functionality for our customers. So how do we spread the deployment and how do we orchestrate deployment across our environments? This screen shows you Bamboo, which is our own tool in which we use heavily to orchestrate our deployments. On the left-hand side, you see the build. It basically has 2 simple steps. One, it actually builds the artifact and runs all the tests required. And the second step is it basically uploads the artifact to a S3 bucket. On the right-hand side, you see the deployment information. So the builder is responsible for creating the artifact and making it available for the deployment. And the deployment is actually used to orchestrate the deployment and spreading it across the different environments. So if you look a little bit deeper, you see here we tag this release as release 47, I believe. Yeah, it's release 47. And we have 6 available environments for this release. In this case, it's already spread across all these environments. But when a new build happens, you see where it's available or not, so it gives you great insight on whether you deployed this specific release to all the environments or not, or whether you need to take it a few steps further. It also gives you great insight in like whether the deployment was successful or not, and if something goes bad, you can dig deeper and say, hey, give me the log information on what went wrong or not. One thing it doesn't do, Bamboo is mainly used to orchestrate the deployment and see, hey, on which environment did I install it. It doesn't execute the deployment itself. So we rely heavily on AWS, so it triggers the CloudFormation script, where we spin up a new Amazon stack, where we deploy a new service. So it's orchestration and insight and giving it traceability, but we don't do the actual deployment itself, because I think Bamboo is not the right tool for that. Let's have a look at testing. I think this is a critical element within microservices, because one of the benefits of microservices, like staying independent of the team, as a team, and move as fast as you can as a team. So isolation is really important. If you lose isolation during your testing, you lose a lot of benefits. So for example, if you depend on the downstream service, which is managed by a different team, which is built in a different technology stack than you use within your own team, and you have to spin it up, you become heavily dependent. So you have to spin up the service. If it's not fast, you get slower. If it's a weird technology that doesn't fit in your own stack, you get a lot of complicated builds, and that's not what you want. So isolation is key in your test strategy. So we have 4 main areas of testing we use. Obviously, there are unit tests. I'm not going to talk about those. We have functional tests. I will touch them slightly. We have contract tests, which I think is the key to make sure everything remains valid. And we have post-deployment verification to make sure once you've deployed, everything is still healthy. So let's have a look at our functional test. The slide says integration test. You could call it like that as well if you like, but that term is a little bit overloaded, I reckon. I think the main important thing for your functional test is to make sure you're not dependent on your downstream services. So we have 2 strategies in place for that. We have a stub for really simple interactions with really simple services, or we have a service mock where we define more complicated interactions. So if you look at an example of a stub, and this is an example from a Spring service, we implement an interface. We really have predefined behavior of that specific service. And we run a service within a specific profile where we say, hey, if this request comes in, you just return a default answer. So we can define the overall functionality and test the functionality of our service without depending downstream. If you want to go a little bit more advanced, we use YMock, where you can spin up a separate service that listens to a specific port, like your downstream service would do, and you can really specify the behavior in a kind of a mock-style way. With that, you can say, if this header comes in on this resource, I return this answer. And with that, you can really define the behavior you would like to test, and you can also define a lot of error states, which can be quite complicated if you rely on a real service, because sometimes it's really hard to get error states in a test environment. So you can really add a lot of error cases, which you can really make your client really robust. The problem with this is that you create a fake world. So you rely on stubs to test the functionality of your service. So you don't know whether that fake world you just created for yourself is still valid. So this is where consumer-driven contract testing kicks in, or contract testing to keep it short. One main point is that it maintains the isolation of your testing strategy, but you still can be sure that you're actually still testing the real thing. So let's have a look at an example. We have service A and we have service B, and they're talking REST to each other, HTTP REST. In contract testing speak, that means you have a consumer and a provider. And this is an example where, as a consumer, you set an expectation. And I made a little assumption that you isolated all your client, or all interaction with your provider is isolated in one client class or whatsoever. In this expectation, you kind of like almost in a mock-style way, you define the behavior you expect. You point your client to your mock, and you start to run it as an isolated unit test, which is not too different in case you would do normal testing. But as a nice side effect of this tool, we use Pact, which is created by the realestate.com.au guys. It creates a Pact file while running the test. This Pact file you can use to send to your provider. So the provider picks up that specific Pact file, and in that Pact file it contains all the expected interactions of your consumer, and you start to fire it away against the real implementation of your service. If you did run this piece, you're kind of sure if all expectations are still matching, your real implementation is still all right. So you just match your fake world against the real one, so you know whether your implementation is still correct. To make sure we didn't miss anything, we run 3 tests in this area. We have both masters run against each other to make sure the latest integration is still active. We run the consumer production against the provider master, and this is to make sure the providing service didn't make any contract-breaking changes. And we use the provider production against consumer master. This is to make sure consumer doesn't go too fast, so they're not going to push anything to production yet, where they don't have any implementation there. And with this, you're still independent, but you're still sure that whether all your API interactions are still correct, which is a great benefit. So the last step we have in place is post-deployment verification, which is actually an automated smoke test which runs against a real environment. We only run it currently against our development environment. We want to push it all the way to production. And that's also part that it runs against the service before we put it back in the load balance. So we only put back a healthy service to get really instant feedback, and we never deploy any fake services, or any failing service, I should say. Obviously, if you want to run it against production, then you really have to be careful about the state you create in your system. You have to clean it up nicely, or bad things could happen or will happen. So that's a tricky one, to find a balance between having a lot of security versus having quick feedback. The last thing I would like to chat about is operating microservices. As you add a lot of complexity to your system, I would like to start with a little quiz. I'm wondering whether you have the answer. You have 100 pounds of potatoes. They contain 99% of water. You dehydrate them to 98% of water. So how much do they weigh now? Any answers? Anyone? All right, I'll give you the answer. It's 50 pounds. For me, this is kind of a surprising answer. It's kind of a no math problem, but it's an interesting one. If you do the same with microservices, it's kind of related. So you have one service that depends on 30 services with an uptime of 4 nines. So what's your new uptime? Any ideas? It get reduced to 99.7, which brings back your uptime of your service from 4 minutes a month. Your downtime from 4 minutes a month to more than 2 hours. So that's a significant change. So by adding a lot of complexity to your system, you really have to think about the reliability of your system and how you deal with failure, because you increase the chance of failure. A good way of looking at it is there are some nice papers around it, is making a distinction between yield and harvest. Where yield is basically your uptime, but harvest is the amount of data you return. So if one service fails, you could say, hey, I throw an error for the whole request. Or you say, I degrade gracefully and only return a small piece of the data, which gives you the ability to increase your uptime and making smart decisions about what you return or not. So, but to be able to do this, it's really important to know your system. So try to feed back a lot of data to your developers by providing a lot of logging information, by providing anomalies to your developers. We use HipChat a lot for it. During the keynote, the chat ops was coined. We're using a lot as well, so we bring alerts in the HipChat room and say, hey, the response time just went up, so what's going on? If things go really bad, we use PagerDuty to wake people up. It's not a fun thing, but sometimes it's required. One final thing I would like to say about visibility and operation is provide the right visibility to trace your requests. If you add a lot of services, it becomes harder to find out, hey, how did your data go to the system? So in this case, you already see the complexity is added. By adding a few trace requests to your response and request, you actually see how the data went. And based on that, you're able to plot graphs like this. This is Zipkin. It's created by Twitter. It gives a great insight like how your data goes, the response time of that data, and where you lose your time or where the error occurred. So that gives you a great insight on how data flows and where you lose your time or if something goes wrong, where it went wrong. So moving forward from here, just a quick summary about the 5 things I would like you to remember. Start with one repository, keep your configuration really close, have one build to create the artifact, have a really strong deployment process in place to use that artifact to spread it across the systems, have the right testing strategy, make sure your service is as isolated as possible with a port and a health check and stateless. Have the right team in place, not only developers, have the right set of automation, and also the people with an ops/infrastructure hat on it, and create the right visibility to your team. Obviously, these are not all the answers. It's really important to think about stuff, because like a lot of questions will come up. How do you deal with the increased error rate in your system? Should you introduce circuit breakers or not? How do you deal with securing your services? How do you deal with service discovery? There are many, many questions. For example, how do you deal with data management when your data is suddenly scattered across multiple systems? So there are many, many answers. Many questions still to answer. So hopefully the answers I gave you already helped. Thank you.